Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and this is part 2 in a series of videos on solving word problems. In this video, I want to look at a particular type of word problem. I'm going to call it a unit word problem. And the basic relationship that you're going to need to understand and use in this type of problem is that unit value times number of units is equal to total value. All right, in this word problem, it says Roland has $25.50 in his piggy bank in dimes and quarters. He has 3 times as many quarters as dimes. How many of each does he have? So we have 2 things that we don't know. They want to know how many quarters and how many dimes. In choosing which one you want to let your variable equal, look at the relationship. He has 3 times as many quarters as dimes. So it's easier to let your unknown be the number of dimes because quarters will be 3 times that. If you do the opposite, you're going to get into fractions. You're going to have to deal with 1/3. So we're going to let D equal the number of dimes. Then let's express quarters in terms of that. It will be 3D. Now I'm going to write my sentence out in words, and then I'm going to replace it with an equation. So what we're dealing with here is a total value of money. So the value in dimes plus the value in quarters is equal to the value in total. So that's really our formula. Value of dimes plus value of quarters will equal our total value. So you're looking for something that will give you a statement of equality. Once you see it like that, how do we express value of dimes, our total value of dimes? We take the value of a dime, which is 10 cents or 0.1, times by the number of dimes, and that's going to give our total value in dimes, plus our value in quarters. We've got a unit value of quarters is 25 cents. We have 3D as the number of quarters, and that adds up to our total value of $25.50. So there's our equation. That's the toughest part. But once you do a number of these unit questions, this will get more and more familiar. So now we're just going to solve it. 0.1D plus 0.75D will equal 25.50. We add this and we get 0.85D will equal 25.50. Divide both sides by 0.85. So we solve for D. D will equal 30. Let's check. So if we have 30 dimes, if we multiply the 30 dimes by 0.1, that will be $3. If we have 30 dimes, the number of quarters we would have would be 3 times that amount is 90. So let's take 90 quarters and multiply by 0.25, and that will equal 22.50. Does this total give us 25.50? Yes, it does. So we've done a check. Now we can complete the problem by answering the question. Roland has 30 dimes and 90 quarters. Let's take a look at a few more. It says Moira has $190 in her wallet in $10 and $20 bills. She has 12 bills altogether. How many of each does she have? So again, we have a situation where we have 2 things that we don't know, and we're going to have to decide, do we let our variable be the number of $10 bills and $20 bills? It really doesn't matter. So I'm just going to let X equal the number of $10 bills. So then we need to express the number of $20 bills in terms of X. So what do we know? We know there are 12 bills altogether. So when we're talking about number and not value, we concentrate on that rather than the $190. This represents the number of bills, so we look at the number of bills. So if there's 12 bills altogether and X of them are $10 bills, 12 minus X would be the number of $20 bills. Once we've used that value, we don't worry about it anymore. What we want to make our equation about then is the value of the money. So we know that the value of the $10 bills, or value in $10 bills, plus the value in 20s will equal the total amount of money that she has. So that's what we're going to use for our equation. The value in $10 bills, remember, is the number and the unit value. So the unit value is 10 times the number is X. So 10X would be the value of $10 bills. Then the value in 20s will be the unit value, which is 20, times the number, which is 12 minus X. So that's going to give me my total value in 20s. And the total value I know is $190. So there's our equation. Let's solve the equation. We're going to distribute this 20 first of all. So I'll have 240 minus 20x. Let's combine our x terms. So we're going to have 240 minus 10x equals 190. Now if you can manipulate and move your terms in a way that you get your x term positive and isolated, that's fine. I'm just going to take a couple of steps to do it. I'm going to add 10x to both sides because I want it to be a positive term. And now I'm going to subtract 190. So I'll get 10x equals to 50. I divide both sides by 10. And x is equal to 5. Let's do a check. If I have 5 $10 bills, and I have 12 bills altogether, the number $20 bills will be 12 minus 5 will equal 7. So let's just do a little bit of a check in terms of their value. So $10 times 5 of them will be $50. $20 times 7 of them will be $140. If we add those amounts up, I do get $190. So I know my answer is correct. So I just make a little statement. Moira has 5 $10 bills and 7 $20 bills. Let's look at one more. Okay, this next problem is very similar to the one that we just did. I just want to do another example to reinforce what we've learned and hopefully start getting a pattern set up for you. So the question says, a movie theater charges $13 for adult admissions and $9 for child admissions. If 261 tickets are sold for a total of $3,201, how many of each type of ticket was sold? Again, we have two unknowns. We don't know how many adult tickets were sold. We don't know how many child tickets were sold. We let our variable represent one of them and it doesn't matter which one. So I'm just going to let A equal the number of adult tickets or admissions. Because I'm talking about the number, I want to know how many tickets were sold in total. I don't care about how much money was brought in at this point. I just want to know number. There are 261 tickets sold altogether. So if A of them are adult tickets, then 261 minus A will be the number of child admissions or tickets. So now that we have both unknowns defined in terms of one variable, I'm going to look at setting up my equation, and my equation is going to be about the money. the money brought in from the adult tickets plus the money brought in for the from the child admissions will equal the total money of brought in. So you can write that in words first if you want, or go straight to the equation. It just depends whether it helps or it's just a waste of time for you. If you do decide to write the statement in words, it would be the adult dollars plus the child admission dollars will equal the total dollars brought in. So that might just help you set up your equation. How do we express the total value of the adult tickets? Well, we take the unit value, and the unit value for adults is $13. We multiply by the number of adult tickets, which is A. So that's going to be the total value brought in on the adult admissions. The child amount will be the ticket price for children, which is 9. That's our unit value. The number of units is 261 minus A. Those two amounts should add up to our total of 3,201. Now that we have our equation, we're just going to solve it. 9 times 261 is 2,349. 13A minus 9A is 4A. Now we're going to subtract 2,349. So we have 4A equals 852. Divide by 4. And A is going to be 213. So we're saying that there were 213 adult tickets sold. And then 261 minus 213 would be 48 children admission. Let's do a check. $13 times 213 admissions will equal 2,769. $9 admissions times the number is 48 multiplies to equal 432. When we add this up, it does equal 3,201, so we know the answer is correct. So we would say 213 adult and 48 child admissions. You can make a nicer statement than that. I just don't have a lot of room. So I would suggest that you go find this type of word problem. You probably have them in your homework, and practice. Just concentrate on this type so that you reinforce the concepts that you're using and you develop some skill and confidence. And then when you're ready, let's then move on to the next video, which is a different type of word problem. Until then, take care.